Good morning, students. Now I am going to take this small uh, definition because that makes basis for the next theorem. Okay, so I am taking this particular theorem so that it will be very useful for you for understanding the next theorem. Okay, now I'm going to talk about some definitions on a branch, weight, and centroid of a graph, of a connected graph. Now, what is a branch at a vertex U of a tree? So, tree, it is what we are discussing at present. A tree is what? A connected graph without cycle is called a tree. So see the picture there, it is a tree where the vertices are given in blue color and the branches are given in white color. Now what is a branch at a vertex U of a tree? T is a maximal subtree. You see here, this is a small part of a big tree, okay, and U is a vertex. Let me correct, U is a vertex. Now the branch at the vertex U is a maximal subtree. Okay, so now maximal subtree containing U as an end vertex. So suppose U is an end vertex. So how many trees are, how many branches are here, how many maximal trees are here? There are 3 branches only. Make 3 branches. Okay, therefore the branch at a vertex U of a tree is a maximal subtree which have the end vertex as U. Okay, that's what we have to understand. Now there are 3 branches are here. Am I correct? Therefore the dimension of U, or the degree of the vertex U, is 3. Suppose 4 branches are here, then the degree of U is equal to 4. Suppose 1000 branches are here, then the d of U is equal to 1000. Like that, the degree of the vertex. The branch of a vertex is the maximal subtree. Here only 3 trees are here, and the branches are B1, B2, and B3. Now what about the weight of a vertex U of T? Is the maximum number of edges in any branch. Now look at this, 3 branches are there, B1, B2, B3. The maximum branches here are only 2, that is in the branch 1 and in the branch 2 there are maximum number of edges are there. Am I correct? There are 3 edges, 1, 2, 3 edges in the branch 1, branch 2 also 3 edges are there, and this is called the weight of U of the tree, the weight of the vertex U of the total tree. That's, we call it as weight of a vertex. The next one is about the centroid vertex. Centroid vertex is the minimum weight. What is a weight? Weight is the number of edges, maximum number of edges in any branch at U. The max number of branches in any vertex at U. Okay, and that's called what? Weight of the vertex U. Suppose it is a minimum, then it is called a centroid. I mean the weight is very minimum, the number of branches should be very minimum, then that's called a centroid of the vertex V of the tree T. So like that, in so many branches, the big branches, so many vertex would be there whose weight would be very, very minimum and equal, and those vertices are called the centroid of the particular vertex, centroid of the particular tree. So group of centroid vertex of a tree is called the centroid of the tree. So actually centroid means the collection of centroid vertex u of a tree. That's what we have to understand. Okay, now let us come to the next definition, that is called now what is that? Behind that I want to see that. Oh, contraction of an edge. What is a contraction of an edge? Okay, so contraction of an edge is nothing but we are removing the edge of a graph. G is said to be contracted. The edge is contracted. How? If it is deleted from G and its ends are identified. So if an edge is deleted from the particular tree and then the ends are identified, then we say that contraction takes place for the edge, and we are representing as like this, G dot E. Now take the first graph there. When E is contracted, that means deleted, we will get the right hand side picture, and the representation is G dot E. Okay, so when G dot E comes, when E is contracted, we get this particular picture. Okay, you see there, V4 is here, V1 is here, and this is contracted. You join these two. Okay, join these two, you will get this particular picture. That's called contraction of an edge, E. And then you come to the second picture there. Again, if E is contracted, the second picture, this is a loop. V1, V2, V3, V4 are the vertices. When it is contracted, what we'll get, this straight line, that is, this is V1, V2. Okay, you will get that straight this one, and this is V2, V3 is this one, and this is joined with this, and this is joined with this. Okay, so that you will get this particular picture. Okay, that's what you have to understand. Actually, I will take that, then you will understand that very clearly there, and then I will take this one. Okay, now this is what V1, and last one is what, V3, and this is V2, V4. V2 equals V4, that way. Okay, this small loop comes from this particular one, joining together, you will get this. So this is a contraction of E from this particular graph G. Okay, similarly, last picture there, which is contracted, the edge E5 is contracted, then this edge joined with this one, you are getting this one, and this is as it is, this is one, and this is another one. That's what three edges we have. Last edge we have as it is. Okay, now look at that, and we are getting a new picture here. Am I correct? So ends are identified. Ends are identified there. So this new picture we are getting like this, a new graph we are getting like this, is called contraction of an edge. Contraction of an edge. Okay, so this is what very clearly you have to understand, because the future theorem you should know about the contraction. This is one formula. By using that we can find out the number of spanning tree. If the picture is given to us, I mean graphs are given to us, or trees are given us, or the connected graphs are given to us, then we can find out the total number of spanning tree from this particular formula. We will see this in the next class. So thank you very much for listening so far. Thank you.